Curious, setting the scene. In the early 1990s, the web was built on two simple pillars. HTML provided the structure of a page, and CSS provided the styling. If you load up a vintage Netscape browser interface from that era, you immediately hit a wall. You were looking at a static document. The pages were read-only, with no internal logic. If you wanted to submit a form or click a simple button, the browser couldn't process the action itself. It had to throw the entire page away, send a request back to the server, and reload a brand new document from scratch. As internet adoption grew, the web's document-based roots couldn't keep up with user demand. People wanted to engage with software, not just read digital flyers. In 1995, a developer named Brendan Eich was tasked with solving this. He needed to build a logic layer that could run directly inside the browser, on hardware exactly like this bulky CRT monitor. His solution was JavaScript. He built a high-level, interpreted programming language designed specifically to fill that interactive void. If HTML is the skeleton that structures a web page, and CSS is the skin that paints it, JavaScript was engineered to be the nervous system. By embedding that nervous system into the browser, a single window could finally process data locally, allowing for the same complex logic previously reserved for dedicated desktop software. This diagram shows the anatomy of a modern web page, separating into three distinct layers. At the bottom is the structural wireframe, or HTML. Above it is the painted surface, the CSS. And hovering on top is the JavaScript logic engine, acting like an interconnected circuit board. When you interact with a page, that circuit layer sends instructions down to the wireframe. This is called manipulating the document object model, or DOM, which is the programming interface that represents the web page as a structured tree of elements. Because JavaScript can target the DOM directly, it updates just that single piece of content in real time. The rest of the page remains locked in place, removing the need for a full refresh. Under the hood, JavaScript pulls this off because it is a dynamically typed, prototype-based language. Developers don't have to declare variable types up front, and objects inherit properties directly from other objects, instead of using rigid class blueprints. That architectural flexibility allows developers to write highly adaptable code, making it the ideal tool for building interactive features on the fly. But there is a major computational constraint. This visualization shows how JavaScript is single-threaded, meaning it processes commands through a single pipeline, handling exactly one instruction at a time. Skeptical. If the language can only do one thing at a time, how can you type in a search bar while the web page simultaneously downloads a massive dataset from an API, all without the screen freezing? This flowchart illustrates the solution, the event loop and asynchronous programming. When a heavy task like a data fetch arrives, the main thread pushes it off into a side queue. By offloading the heavy lifting, the primary pathway stays completely clear. The browser continues to respond instantly to your clicks and keystrokes while the background request is still in flight. JavaScript manages these delayed instructions using features like first-class functions, which allow functions to be passed around as arguments, and closures, which ensure those functions remember their original data environment even after waiting in the queue. This orchestration allows the browser to remain responsive, even during complex background calculations, preventing the interface from locking up. For years, developers viewed JavaScript strictly as a front-end tool, entirely confined within the borders of the web browser. But eventually, they realized that the same non-blocking asynchronous design that prevented web pages from freezing was also efficient at handling thousands of simultaneous data requests on a server. This diagram shows the creation of Node.js. It's a runtime environment that allowed developers to transplant JavaScript out of the user's browser and execute it directly on backend servers. By jumping across that gap, developers could suddenly build complete full-stack applications. They could write the user-facing interfaces and manage the heavy database logic using one single unified programming language. That spatial expansion didn't stop at web servers. Developers built frameworks like React Native, allowing JavaScript to power native applications directly on mobile phones. Then, they used environments like Electron to package that same code into standalone software for desktop computers. To maintain order and ensure systematic updates across this massive ecosystem, the language was formally standardized under the name ECMAScript. Today, this single ecosystem handles the logic for the browser, the server, and the mobile device. The same code that once validated a 1995 web form is now running the backend of global banking systems and the interface of almost every smartphone app.